In lesson 6.2, we're going to be talking about parallelograms and all of the different properties that are true for a parallelogram. Now we know that a parallelogram has four sides, so it is going to be a quadrilateral, but more specifically, it's a quadrilateral with two pairs of opposite sides that are parallel. So by definition, the opposite sides are parallel, which is what I'm showing here with the arrows. The shorthand symbol for a parallelogram, sometimes you might see this symbol followed by, if I were naming this would be parallelogram ABCD. So let's talk about some of the properties of a parallelogram. If a quadrilateral is a parallelogram, its opposite sides are congruent. So as I look at my diagram to the right, I know that my side AD and BC would have to be the same length, and AB and DC would be the same length. If a quadrilateral is a parallelogram, then the opposite angles are also congruent. Opposite angles are going to be the angles that are across from each other. So angle B and angle D are opposite. Angle A and angle C are opposite. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Consecutive angles mean angles that would be right next to each other. Consecutive angles here would be angle A and angle D. Now, you'll remember that if my lines are parallel, these would actually be considered same side interior angles. And we had learned in chapter 3 that they would be supplementary. Now, not only does that work for A and D and B and C, but it also works going horizontally. These would be consecutive angles as well. So, we know that our consecutive angles are going to be supplementary. If a parallelogram has one right angle, then it is going to have four right angles. Because our consecutive angles have to be supplementary, if this is 90, then this angle here is going to have to be 90. And likewise, going across, if angle E is 90, angle F is going to be 90. If a quadrilateral is a parallelogram, then the diagonals bisect each other. We know from semester 1 that bisect means to cut into two equal pieces. So my diagonals going across from A to C and B to D, they bisect each other. They cut each other in half, meaning J would be a midpoint for both segments. A and AJ would have to be congruent to CJ. Likewise, DJ would have to be congruent to BJ. Now, that doesn't mean that they are all four congruent segments. The diagonals of a parallelogram do not have to be the same length. And in this particular diagram, my diagonal from A to C is shorter than my diagonal from B to D. Finally, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into congruent triangles. Because, looking here with one diagonal, I have two triangles. I know my opposite sides are congruent. And this would be my shared side. I can say, well, those two triangles would have to be congruent, I'm showing the side, side, side shortcut. So let's take a look at some of the questions you might encounter in lesson 6.2. They're going to ask you to solve or to find some of the missing values. In example A, number 1, they want us to find the measure of angle S and find the measure of angle T. Well, going back to what we learned, if I have an angle that's 110 degrees, we know the opposite angles in a parallelogram are congruent. Angle S and angle R are opposite. I also know that my consecutive angles need to add to 180 degrees. And so, my measure of angle S, we would know to be 110 degrees. My measure of angle T would have to be the supplement, which would be 70 degrees. Question number 2, they're asking us to take a look at finding some side lengths, finding the length of segment QR and finding the length of segment PS. Well, because these sides are opposite from each other, I know the opposite sides are going to have to be congruent. We're simply going to take those and set them equal to each other. 3x minus 15 is going to have to equal 2x plus 3. Now, if I get my x's on one side, and I move my numbers to the other, we would end up finding that x is 18. Now that's not my final answer. They're asking me for the length of QR and PS, meaning I'm going to need to take that 18 and substitute that back in. Now because both of them are going to be the same, I don't necessarily have to do it twice because they would have the same length. And plugging that back in, we're going to find that segment QR and segment PS are going to have a length of 39 units. Okay. Question number 3. We're asked to find the value for our variables x, y, and z. So if I take a moment to locate those, first let's look for my value x. I can see here they're telling me that QT has a length of 5x, but my opposite side here has a length of 27. And so because I know that my opposite sides are congruent, we can simply say that 5x has to equal 27. Now I know that when I divide that, it's not going to come out evenly, and that's okay. 27 divided by 5 happens to be 5 4/10, or 5.4. And we'll leave our answer as so. If I'm looking to solve for y, I see here that this is telling me from t to p is 2y minus 5, and p to r is y plus 4. Well, I know that my diagonals bisect each other, meaning that p would be the midpoint. So I'm simply going to take my 2y minus 5 and set that equal to the y plus 4. Again, if I subtract y from both sides and I add 5 to both sides, we simply find out that y is equal to 9. Lastly, I'm looking for my value for z. Z, down here, 3z degrees. And so this is going to be referring to this angle right in here, 3z. Now I know that my opposite angles are congruent, but I also know if I have some parallel lines, 3z and 33 are going to be considered alternate interior angles. Alternate interior angles are equal, so 3z must equal 33, or z must be 11 degrees. In example B, it tells me that we have 3 vertices of my parallelogram JKLM, J is at 3, negative 8, K is at negative 2, 2, and L is at 2, 6. Find the coordinates of vertex M. Well, as I look, these are plotted over to the right, J, K, L. There's a couple different ways that you could work this problem, but I happen to think the easiest way is by thinking about the slope. Okay, now I'm just going to connect my points. I know that my point M, if I'm forming a parallelogram, is going to have to be somewhere in this region or in this area. I'm going to take a look at the slope from K, or the slope of KL. I know that in a parallelogram, my sides are parallel. And so when I look at K to L, my rise over my run. Well, this happens to be a rise of 4 and a run of 4. And so looking at my slope of KL, we have a slope of 1. I know that my point M is going to have to be in this region, meaning from point J, I'm actually going to use that same slope because my lines are parallel. And I'm going to go ahead from point J and I'm going to go up 4 and over 4. And that would have to be my location for point M. Point M looks like my coordinates to be 7 units over and 4 units down. My coordinates then 7, negative 4. You could also maybe think about using some distance formula to help you out there. Really what I did, I found my slope, but I also formed a right triangle here. And you could kind of think about using that as a Pythagorean theorem as well. Finally, example C. They're going to ask us to do a little bit of proving on this one. It tells me that ABCD is a parallelogram. They're wanting me to prove that triangle AEB is congruent to triangle CED. How do we go about doing this? Well, we're going to set it up like we did in previous chapters, and we're going to use our 2-column format. I'm going to say that we're given ABCD is a parallelogram. Now, as I look at my triangles here, I'm trying to prove AEB and CED, these two triangles on the side. Now, I have to think about, what do I know about a parallelogram that would help me out? Well, I think most helpful would be that my opposite sides are congruent. Opposite sides congruent, well, I'm really only concerned about this side and this side, so that's the only one that I need to use. Those are the parts of the two sides that have something to do with my triangles. So I'm going to say AB must be congruent to DC. This is how they would write their reasoning in the textbook. They're going to say, if parallelogram, then opposite sides are congruent. Now, it doesn't have to look exactly like that, but that's one way to shorthand it. What else do I know? Well, I know something about the diagonals. I know that my diagonals bisect each other. And if they're going to bisect each other, E is my midpoint. I know that this side must be congruent to this side. I also know AE must be congruent to CE. Well, I'm going to go ahead. If I make that marking, I got to put my statement down. BE must be congruent to DE. AE must be congruent to CE. How do we know that? Well, if a parallelogram, then diagonals bisect. And I actually have enough to prove that my triangle AEB must be congruent to triangle CED. Why? Well, we have shown the side, side, side shortcut. Now that's not the only way to do that proof. You would see, looking at that picture, I maybe could have used some alternate interior angles, or I could have used some vertical angles. But for me, the first thing that I saw was side, 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 and so that's what I went with. If you have more questions on this, please step